Hello and welcome. We're going to be talking about stoichiometry, specifically empirical formula. So I had a bunch of questions. A lot of people are asking about the TI-84 Python. So look, when you go and press the program key, like let me quit. If I press the program key, it asks me if I want to go TI Basic or Python applications. You can still run this on TI Basic on a Python TI-84 calculator, just so you know. We're on iteration number 7, KEMSOLV 7. Just so you know. So for the other people, here we go. We're going to talk about stoichiometry, specifically empirical formula. This thing has been a beast, so bear with me. This has been the most frustrating thing I've done on a TI-84 calculator. So look, I do want to show you. I have an example here before we actually go to the solver. So if you had something empirical formula example where you have iron is 69.6% or 69.9%, and then oxygen is 30.1%. What you want to do is divide it by the molar mass to find out how many moles you have. So for iron, it's 1.25, oxygen 1.88. You're going to basically divide by the smallest number. I'm going to get 1 to 1.5 ratio. But what you need is a whole number ratio. So 1 to 1.5. So you're like, oh, I need to get this 1.5 to an integer. So multiply by 2. Do also for the iron, you do 1 by 2. So it's a 2 to 3 ratio. Sorry. So it's Fe2O3. Okay. Now, unlike that, in my a little more prehistoric program, when I do two elements, it's going to be like A and some number X, and then B with a subscript of Y. You'll see this in a second. So for this two element, what is this? Empirical formula. The mass is 40 for element A. Now look, this is typical. This is typical, like, let's be devious chemistry teachers here. The atomic mass is 12.01. So look, we're still on element A. So we're going to enter 12.01. Don't just blindly say, oh, I'm just going to put the next number here, enter it. Just be aware of what you're doing here. So the mass of A is 40. Atomic mass of A is 12.01 grams per mole. Okay. Now we'll go to red for element mass B. Oh, here red looks like blue. Sorry if you're colorblind. It probably freaked you out. So mass of hydrogen is going to be the 6.71. And then the atomic mass of hydrogen in this case is 1.008. Okay. Now, blah, blah, blah. It goes A, B2. So in this case, we've got, I'll do it in orange. Why not? My dad went to Syracuse. This would be A, B2. Now, here's the thing. You want it, don't write A, B2. Your teacher's like, what did you just smoke? Because we have carbon and hydrogen. So remember, you want to use these elements. Like that's going to be your A is your C. So it's like CH₂, right? Simple substitution. Remember, if you start writing AB2, ooh, bad. So please do watch this video, especially if you need help in chemistry. Chemistry isn't your best subject. Man, know how to use this program. Otherwise, you are going to get smoked. Okay, sorry. I no offense there. Okay, no offense meant. Okay, in any case, let's go to the second example. Two elements again. So mass of A is 24.3. Okay, so this is kind of boring. If you already get the gist, just like, subscribe, go on your merry way. But if you want to see some examples, because it does do more complicated examples, mass of mag is 24.3 grams. The atomic mass is 24.31, or the gram formula mass, or the molar mass, some people call it. I don't know. It's all interchangeable. I'm more a math guy than a science guy, so flame me in the comments if I'm crucifying or if I'm really mistaking what I'm doing. So the mass of B is 16, and the atomic mass of B is also 16. Yeah, that actually works out pretty well. So we got AB. Okay, great. So that would be Mg as my first thing, and then O as my second, right? Right? Okay, so that's no subscripts, just means a 1. So we don't write it, we just write MgO. We don't write Mg1O1. I know, a little quirk of science here. Okay, we continue. Carbon, hydrogen, another two element thing. So remember, it's going to be C something, H something. We don't know yet. Okay, it's C, H. Okay, so the mass of A. Now, it says 79.9%. You're like, what do we do? We're just going to enter it like it's 100 gram total of the sample. So 79.9. And the atomic mass of carbon, 12.01. And I know some periodic tables and charts and whatnot might just have it as 12. Shouldn't be that big a deal because my tolerance is pretty small, but not like super tiny for these ratios. Mass of hydrogen in this case is 20.1%. So we're just going to enter 20.1. And the atomic mass, 1.008. Okay, there we go. So we got AB3. So that's CH3. Again, we understand that there's a 1 if we don't write it, right? Just like, like if someone says, hey, how old are you? And you say, hey, I'm 16. Unless you're talking to, a math major, you're like, you didn't say positive 16. I mean, dude, there's no need. It's understood. Okay, it's understood. Okay. Now we'll go 3 element examples. Okay, so mass A, we're going to go, again, we got the percent thing. So we're just going to write that it's like 40 grams, right? And then the atomic mass of A, so carbon is a 40, and then that's going to be 12.01. So 12.01, enter. Okay, and I'll go green for the next thing. The hydrogen is a 6.67 here. And then that is going to be 1.008. The atomic mass would be 1.008. There we go. And then we'll go blue for the last guy, the oxygen, 53.3, 53.3. And then we're going to do 16 for atomic mass. There you go. And then we got, A, B, 2, C. Again, don't write that, right? We're going to go CH₂O, right? Don't write A, B, 2, C. Dude, don't write that. Don't write that. Write CH₂O. Like, you have to be awake. You can't go fully asleep in zombie mode in this. You do have to pay attention to what elements you're using. Okay, maybe in the next iteration or something, I'll start listing common elements. But this program takes so much memory. Like, if I add to it, if I add like a line of code, it's going to be like too much to fill most calculators. So people are going to be pissed. They're going to buy this calculator program. They can't run it because their calculator doesn't have enough memory. So I might have to split this up into 2 separate programs in the future. Don't worry, everybody who bought it already, you're going to get grandfathered in. You'll get free updates. Okay, so again, we're going to go to, 3 elements. I skip around a lot. Maybe I have ADD, undiagnosed, because I grew up in the South and I'm older. Okay, so the mass is 2. And the atomic mass of H is 1.008, 1.008. So I'm trying to color code it for you guys. We'll go blue on the next thing. Blue is this color. And then, so the mass of S is 32.1, so 32.1. There we go. And then the atomic mass is 32.06. Okay. And then we'll go green for the last guy. And the mass of O is 64, so we can go 64 here. And then we're going to go 16 for the atomic mass of oxygen. Okay, so it's A2BC4, so it's like H₂SO. We're going to use those. If we don't have a number as a subscript, meaning the number below, we're not going to put anything. So it's H₂SO4. Fantastic. Everybody's happy. Everybody's happy. Everybody's liking the video. Everybody's going to mcstudium.com and buying it to save your bacon in chemistry. Yes, indeed. Okay, so again, we got a 3 element as our last example. Mass of A is 3. This one will go blue. That's 3 and 1.008 for the atomic mass, so 1.008. So this mass is the mass in the sample, or the percentage in the sample, that first number. The second number is the atomic mass, okay, or the gram formula mass or the molar mass. I think they're all interchangeable terms. Again, I'm not a science guy. I'm a math guy. I'm just kind of moonlighting here. Mass of B, 31 grams. And then it's saying approximately 31. Let's go 30.97. If I screw up, I'm going to have to reshoot this whole video. 30.97. Let's see what happens. And they'll go green for the last element. Oxygen is 64, so the mass is 64. And then the atomic mass 16. Let's see what happens. Okay, cool. We got A3BC4, so that's H₄SO. Those are elements. And the subscripts would be 3 for the first one and 4 for the last one. H₃PO4. Yes! Like, subscribe, and remember, you buy this program from mcstudium.com, you get free updates for life. The next iteration will have help menus, so you know which units to use. And I might work on the half-life rates because somebody just contacted me about that today. But I wouldn't expect that out till next week because my coding skills are minimal. So good luck. and comment for changes you'd like to see. Okay, take care. Talk to you next time.